In this video, I'm going to show you how to measure frequency, duty cycle, and pulse width using the PicoScope. In fact, I'm going to show you two different ways of measuring, taking each of those measurements in the scope. Now, if you're not familiar with the definitions of frequency, duty cycle, and pulse width, I have another video that explains those, and I'd recommend that you watch that first and then come back to your PicoScope and you can practice measuring these waveforms. So first, let's talk about frequency. Now, I have a digital signal here, and as I zoom in, you can see these pulses. Now, frequency is the number of occurrences per second, and the first way to measure that is I would just come out here and mark off one occurrence when this switched on, and I might zoom in so that I can be more accurate in the placement of my rulers here, and then I'll mark off the second occurrence. Now, if I look over here in the lower right hand corner, I should see my frequency, and that's marked off at 49.77 hertz. Really, it's probably 50 hertz. You'll see as I zoom in, I can get more accurate in the placement of my ruler there. I can do the same thing over here and get a more accurate measurement. So now I'm at 49.99 hertz. Okay, so that's frequency. Now the next one is duty cycle. To measure duty cycle, I'm going to put these rulers away and pull out these rulers over here on the right hand side. And again, I'm going to mark off one cycle. See if I can be accurate in my placement of my rulers again. And you'll notice that this says 360 degrees. I need to change this, so I'll come down here to the rulers menu, and I'm going to change this to percent, because duty cycle, of course, is measured in percentage. So there's 100% of one cycle. Now, if yours says anything else right here, you can type in the percentage by double-clicking on that box and enter your own percent. Okay, now I want to find out what percent of this cycle was the signal turned on, or was the voltage high. And so I'll bring a ruler over here and place it right there. And I can look up, and it should give me my duty cycle percentage right there in this box at 27.88%. So there's duty cycle. Okay, so the third one is pulse width. So again, I'll click this X to put my rulers away. The pulse width is just the amount of time that this pulse was on for. Now you can measure either the high pulse or the low pulse. Typically, we'll measure the high pulse because that's the on time. We could measure the low pulse, or the amount of time that it was off for as well. If I get these rulers placed somewhat accurately here, it shows me that my pulse width, or the length of time this pulse was on, is 5.595 milliseconds. And that's how you measure pulse width. Now I'm going to put the rulers away. Actually, I'm going to spread these rulers out over a larger time frame here. And the other way that we can measure these things is to come down here and add a measurement. So I'll click on this box and add a measurement. On channel A, I want to choose to measure my duty cycle during the whole trace, or I can choose to do it between my rulers, and I'm going to do it between the rulers. And I'll click OK. Now I've got a measurement down here. Now this is a little bit hard for me to read, so one thing that you can do is come up here to measurements, and you can increase the size of the font. So now I can see my measurement much better there. Now I'm going to add another measurement. On channel A, I'm going to look for frequency, and I'm again between the rulers, and I'll add that. Now I have a frequency, and then I'm going to add one more measurement of pulse width. So there's my high pulse width, and there's my low pulse width. So I'll choose high pulse width between my rulers, click OK. And now I have those measurements probably much more accurately than the way I did it, where I placed my rulers on the lines. I've got a duty cycle of 28.01%. I have a frequency of 50 hertz and a pulse width of 5.6 milliseconds. And those are very close to the measurements that I had, but these are probably actually the more accurate ones. Anyway, that is two ways that you can measure your frequency, duty cycle, and pulse width using your PicoScope. And you can do that to all kinds of signals. Of course, if you're going to measure duty cycle or pulse width They need to be digital signals. But you can measure frequency with analog or other types of signals as well, because you don't have to have that clear on and off. I hope that helps.